So our supply.py program was pretty impressive, if you ask me. We did an interesting calculation, and in just 15 lines of code with plenty of comments and spaces. But one problem, besides the repetition in the logic, was that it couldn't take any input from the outside world. It's just sort of like locked in its own little box here. And usually programs are only interesting if they get to interact with the world, right? Like if you're trading Bitcoins or something, you want to know what the price is. And you need to get that from outside. So the simplest way to get input into your program, we call this I/O, input output. So input is the simplest way is to run the program and allow the user to enter something in on the terminal. So let's make that now. And I'm gonna so I want you to create a file, and this time let's create it on the terminal. So touch user input.py. The touch command creates a file. As you see, it opens over here. So we can double click that, it opens up here. I'm going to close supply.py. So in order to get user input, we'll say, let's say num equals input enter a number, and I'm going to do a colon and a space, and you'll see why in a second. So I didn't spell that right. Input, and let's print it. So get user input and print what they gave you. So I'm going to enter a 2. And it says yes, or it says 2, sorry. So now that we have one number, what I'm going to try to have us do here is build a little bit of a calculator, something that can take in 2 numbers and add them, for example. So to do that, we need a second number. Let's call it, actually let's call this one Y, and let's call this one X. Those are good names for numbers. And we'll print them both. You can set in the print statement, you can separate values by commas to print multiple things. Enter another colon space. And so the reason for this colon space, this time I won't have it. I'll just have the colon. And if we run it, you'll see the first time, see how it says enter number, and there's a nice little space here in front of my cursor. And then with this one that doesn't have the space, see how it's kind of cramped? It looks kind of funny. There's not enough space there. That's why we have that's why I'm sticking the space. It's just kind of a little formatting thing. And so I entered in 2 and 3, and it prints out 2 and 3. So now our problem is how do you add these? So that's your exercise. I want you to pause the video and try to figure out how to add X and Y and print that. And here's the tricky thing. The output, or what input gives you is a string. So you need to turn X and Y from strings into integers in order to add them. So pause the video and see if you can figure that out. So I would make a variable called maybe something like sum, and I would say it's equal to int of X plus int of Y. Just turn them into integers and print out the sum. So let's say 5 and 20 is equal to 25. All you had to do is cast them to integers. If you don't do this, which I'm sure some of you forgot, if you do X plus Y, it'll give you an error without turning them into integers first. We could also do something a little different. We could allow decimals, right? So right now, if we try to run this, like if we do 1.5 and 2.5, it will say, sorry, basically I don't know how to read this. So the way this error message works is if you start from the top here, traceback says like, these are all the steps that led to your error. And then it says which file it was, our input.py, what line it was, line 4, and it shows you the line just to make it a little easier, because sometimes these are all in different files, so it's hard to actually go look up exactly what the line was if you just given the file name and line number. the type of error it was. Python has probably 20 or 30 different built-in types, and you can define your own for special errors. If you're building like a Bitcoin node, maybe you'd have like a protocol violation or a bad signature error, like a consensus violation or a bad signature error, something like that. Double spend might be one of them. And then this is specifically how it's describing what went wrong. It says invalid literal for int with base 10. So when it tries to turn this string into an integer, it sees a character that it doesn't recognize, basically the period there. It's like, I don't know how to turn that into an integer. And so that's our problem. And one way to fix this is there's this thing remember we saw there were decimals earlier? Those are floats. So here you can just cast it to a float. And now it knows how to deal with that, because float knows how to parse the dot, basically, which is pretty cool. It's just like, give it another function here, and it will all of a sudden magically know how to deal with it. So that's pretty cool. So one thing that's kind of a problem in our program, and so when we're in this situation, the user will enter in some information, and sometimes we want to do different things depending on what they give us, right? So, maybe let's say maybe we want to check if this number is even or odd, right? Or actually, and so before we go any further, I want to have you do one more exercise. I want you to turn this into a product. Instead of adding x and y, I want you to multiply them. So pause the video and see if you can figure that out real quick. All right, this one was kind of a doozy. All you needed to do was multiply them, and I'm going to change the variable name just for readability's sake. And the star is the operator for multiplication. If we run that, 4, 9, gives you 36. So that's pretty simple. All we had to do is change one little thing, and now it does something completely different. So one other thing we might want to do, let's say I'm going to delete all this up to x. Like, let's say given x, maybe we want to do some checks on it. Like, an interesting one would be like whether it's even or odd, right? That would be kind of a cool check. So you say if, and then condition, and I'm just going to make condition a variable, and we'll like alter it a little bit. If condition, and you have a colon, and then when you hit enter, you see how it tabs you over 4 spaces. So it's like this code is like nested in the if. So if the condition is true, then do this. We'll just say print true. Else, and we have to do else at the outer kind of to the left, right? So we're back all the way to the left here. And then we have a colon after it. We say print false. So let's try running that. So it prints true because our condition is true. What happens if we change it to false? Now it prints false. How about 1 is greater than 2? A false statement, right? So it should print false, and it does. But if we switch that to less than, run it again, all of a sudden it's true, which makes sense. 1 is less than 2. So here's another interesting condition. What if we want to see let's say we have our x number. How would we check if x is even or odd? Right? If we hop back down into the REPL here, if you remember this modulus operator, percentage sign, given a number, let's say 5, if you do the percentage sign in 2, it'll just tell you what's left over after dividing by 2, which is essentially what even and odd means. So if 1 is left over, it means it's odd. 2 does not evenly divide 5. If we change that to 4, 0 is left over. It means 2 evenly divides it, and so 4 is an even number. So here's an exercise. How would you modify this condition? So you could put it here, or you could just put it right in here. How would you modify this to take x and tell you whether it's even or odd? Pause the video and see if you can figure that out. So what you'd want is you'd want int of x mod 2 equals 0. And let's name this to maybe like is even, right? And then we could say like if is even, print even. Else, we'll capitalize that for consistency's sake. Else print odd. If int of x, if 2 evenly divides x, it's even, so print even. Otherwise, print odd. I'm going to hit Control D to exit out of that. Hit the up arrow twice to run it again. Put in a number. Let's say 5. Odd number. Put in 6. Even number. Pretty cool. Let's see if we can modify our function here, or our logic here, and turn it into a function. So I'm going to see how this all does one thing. It sort of just like checks whether a number is even or odd. So one thing you can do is turn it into a function. You can just select the whole thing and hit the tab button to indent it over. So you indent it over once. And then above you say def is even with 2 parentheses and a colon, because this function takes no input. The user gives it. And at the end, you have to go all the way back to the left side now, and you say is even, and that'll run the function. Let's try running it. So ask for a number, just like before. Give it a 7, and it says odd. So this is a way to like group code that's does one thing and sort of separate it from the rest of your program. And this gets really important. Like imagine if you have hundreds of lines of code. It gets really confusing if it's all just one unbroken chain of statements. But if you make functions, and each function has a good name, you can kind of group your code up into little blocks and pieces and compose them and oftentimes reuse the code. For example, is even could be used in 2 or 3 places. If you didn't have a function, you'd have to rewrite the exact same code every time. But having a function allows you to reuse your code, which is really powerful and allows for more concise and oftentimes accurate programs, because you can also test your function. You can write a test to check if it's accurate. And so if it's accurate once, it's accurate everywhere. Whereas writing the same code in 3 places, sometimes it's right in 2 places, and sometimes you accidentally did this. You know, in one of the 3 places you do that, and all of a sudden, well, your code's wrong a third of the time. So that's a function. But this is a function that takes no arguments. There are no inputs to the function. So one thing we could do is we could take this part here where it asks the user for something, and we could actually remove that from the function. We could say, I want the number x, and then you just give that, let's say we give it the integer. We turn it into an integer and then give it to this isEven function. And in order to do that, we would have to have x be an input here, and then here we don't need to turn it into an integer because we already turned it into one. That makes sense? So this is the way our program runs. First of all, it defines a function. It doesn't even do anything. It just like makes a new thing. Here, it goes and grabs a number. It turns it into an integer. And then it gives it to the isEven function. And what isEven does is it checks, hey, is this thing even? If it is, it prints even. If it isn't, it prints odd. Hopefully that makes sense. Maybe we could say like, might be a little simpler to go like this. we'll say get x, and then we'll redefine x to be an integer, and then we'll give it to our isEven function. And that's the same as before. It's just an if statement with a condition. And so if we run it, it's complaining because I'm using isEven twice. Maybe we'll just call that even. Now it won't complain as much. Yeah, that's better. So let's enter a number. 10, even number. So now you're starting to see how you can use functions to break your code up into little bits and pieces. And this is quite nice. So see if you can modify this function to give me a positive, or tell whether the number is positive or negative. Can you do that? Pause the video and see if you can figure that out. So all you'd have to do is, instead of checking for even, and I'm just going to edit it right here, you just check, hey, is x greater than 0? If it is, print positive. Otherwise, print negative. I'm just going to delete that. So I'm just kind of showing you can have it as an external variable. You could just put it right here. This is so short, we'll just put it right here. So just says, hey, is x greater than 0? Otherwise, it's positive. Actually, we should say this isn't quite accurate, right? Because let's say let's try running it. So with 1, it says positive. That's great. What about negative 1? It says negative. But here's the tricky thing. What about 0? It says negative. That's not right. So we really need a third condition in here. We need to check if it's 0 as well. So maybe we could say there's this command elif. So we could check if it's less than 0, and then we'll print negative. And otherwise, so we go to the next line and we go at this indent level here. We'll say 0. I'll use single quotes because I'm using them everywhere else. Else 0. Let's give it a 0. Now it says 0. That's kind of cool. So we have a little program that can take in user input and have a function that does logic, and given different conditions will go into different branches of code. So the way this code works is kind of crazy. It starts here and it sees this function and it sort of like creates a recipe within the program of what to do if somebody calls this. If somebody types in is_even of some variable, it creates a little recipe of what to do when that happens. And so down here, it gets to line 11, and it says, okay, I have an input, so I'm going to go wait until the user gives me something. So it waits. The program execution stops right here until the user types enter. And then it goes here, it tries to turn it into an integer. We've been kind of ignoring this. This will fail if they don't give you an integer. Then it goes to here, and it does go isEven of variable. And so then the program hops back up here, and it checks this condition within the function. It starts executing the body of the function. If it's true, it'll go here, and it'll skip the rest. If it's false, it'll jump down to 5, it'll skip 4, jump down to 5, check if this is true. If it's true, it'll execute this. Otherwise, it'll go jump down here and execute that. So that's kind of a sense of how our program is executing top to bottom. It's no longer top to bottom at all. It's jumping all over the place and skipping lines and going forwards and backwards. It's getting kind of complex and interesting.